Good afternoon. My name is Yone Bedregal. The research that I'm going to present is entitled Determination of the biodegradability of a scale inhibitor synthesized using principles of green chemistry. Mineral scale formations in oil wells and industrial cooling systems can cause significant problems, like the diameter reduction of the pipes, decrease in heat transfer in cooling systems, higher maintenance costs, among others. Prevention methods against scale formations, such as scale inhibitors, have been effective in avoiding this problem. Scale inhibitors are chemical compounds with many active functional groups capable of binding to cations in scale. The most common problems with some scale inhibitors is that on the one hand, they can have carbon and phosphorus bonds, which makes them recalcitrant. On the other hand, they can contain high quantities of nitrogen and phosphorus, which can generate eutrophication in aquatic bodies. In this study, an inhibitor of mineral incrustations, itaconic acid and sodium vinyl sulfonate was synthesized by aqueous phase copolymerization to be applied in oil installations and industrial equipment. The main objective was to evaluate the biodegradability of an oil well scale inhibitor made from polyitaconic acid co-sodium vinyl sulfonate and synthesized under the principles of green chemistry. The specific objectives were to synthesize scale inhibitor under green chemistry principles, to characterize the molecular structure of scale inhibitor by spectroscopy, infrared spectroscopy, and nuclear magnetic resonance, characterize the thermal properties of a scale inhibitor using thermogravimetric analysis, and characterize the number and weight, average molecular weights, and the polydispersity index of a scale inhibitor by size exclusion chromatography, and finally evaluate the biodegradability of the scale inhibitor using the ISO 10707 method. The methodology used was for the synthesis, we used the patent 1058-4048 B2 that describes the process to obtain random copolymer derived from itaconic acid and its isomers and sodium alkenyl sulfonate and use of the product thereof. For the characterization and the biodegradability, we use the methodology described previously in the objectives. The results found are the following. We achieved a successful copolymerization reaction that reached 1.08 kilograms of input for each kilogram of product. The reaction did not generate waste, and it was carried out with low energy consumption and with the use of renewable and inexpensive materials. By infrared characterization, the hydroxyl, carbonyl, and sulfonic acid functional groups of the copolymer were identified. No other functional groups were detected, therefore, the product has no impurities. The thermal stability of the inhibitor reached a degradation temperature of up to 290 degrees Celsius, which will allow it work in ultra-high temperature oil wells and reservoirs. As we can see, by means of proton and carbon nuclear magnetic resonance, the chemical structure of the inhibitor was identified. It was confirmed that there were no residual monomers because no double bonds were found in any of the spectra. The chromatography technique allows us to calculate the polydispersity index of 1.90, which means that the polymer with a good monomer distribution was obtained. And finally, the biodegradability was determined using the ISO 10707 method, which measures the biochemical oxygen demand and the chemical oxygen demand of the test compound over 28 days. The test was carried out at 3 concentrations of the inhibitor. The concentration of 10 and 20 mg per liter obtained 36% biodegradability, and the concentration of 40 mg per liter reached a 90.1% of biodegradability. This allows the inhibitor to be classified as easily biodegradable. The following conclusions were reached. The chemical synthesis of a scale inhibitor with the use of green chemistry principles allowed a successful copolymerization reaction with a mass intensity of 1.08 kilograms of inputs for each kilogram of product. It was possible to characterize and corroborate the functional groups of and chemical structure of the synthesized copolymer by means of infrared spectroscopy and nuclear magnetic resonance. The good control of the chemical synthesis of the scale inhibitor allowed to obtain a monodispersed copolymer. Thermogravimetric analysis showed that the copolymerization of the sodium vinyl sulfonate monomer with itaconic acid increased the thermal stability of the scale inhibitor up to approximately 290 degrees Celsius. The percentages of immediate biodegradability for the concentration of 10, 20, and 40 mg per liter was 36, 36, and 90.1% at the end of 28 days, respectively. And finally, the application of the principles of green chemistry allowed the synthesized molecule to be susceptible to biological degradation. Thanks for your attention.